Okay, hi. All right, let's do this together. This is part 1 out of 2, so I think I'm going to go over like the first 8 or so of these. All right, so to integrate this, you see how there's a common factor in the denominator? So pull that out. So you get 1 over x plus 4. Okay, and then integrate that. So you should get b. Okay, let's do this next one. Alrighty, so it moves along the x-axis, so I'm given position. I'm asked to find velocity. So I do my PVA here, and to go from position velocity, if I go down as a derivative, okay? So go ahead, take the derivative of that, and tell me the first time the velocity is 0. Think about what rule do you have to use to take the derivative of this? Yeah, product rule, so you have to use the product rule. All right, now you're gonna take the product. Okay, so here's sort of your steps. You're gonna derive using the product rule, okay? You're gonna set equal to 0, and then in order to solve it, you have to factor, and then set each factor equal to 0 and solve, okay? All right, let's do it out. So the answer is pi over 4. Oh, I didn't do it out. Haha. All right, let me do it out here. So this is 12e to the negative t times the derivative of the exponent. So it's in times the negative 1. The derivative sign is cosine t. So I'm going to crisscross. So did I show you the answer to that? I hope not. Okay. 12e to the negative t cosine t plus negative 12e to the negative t times sine of t equals 0. So I said factor. You could also, since you have answer choices, just start plugging stuff in, but and see which one equals 0. But yeah, I think factoring is good actually. So cosine of t minus sine of t equals 0. Now when I set each factor equal to 0, I'm going to work this way. So 12e to the negative t equals 0. So when you do that, think, where is e to the negative t, which looks like this, right, equal to 0? It is never equal to 0 because y equals 0 is an asymptote, right? So this has no solution. So if you were confused by that and ignored it, that's actually is what you do. There is no solution to that. So I'm just going to do cosine t minus sine t equals 0. So I get cosine t equals sine t. So there's a couple different ways to do it. I could divide by cosine on both sides and get 1 equals tangent t, or I could just think about it in my head. Either way, 45 degrees is where sine and cosine are the same. Or you could say tangent of 45 degrees, pi over 4 is 1. Okay, all right, let's move on to 3. Okay, so which of the following is the solution set to the differential equation? They give you a tip that means the 5-step thing. All right, this is my initial condition. So you're going to separate the variables, etc., etc. I would leave the 2 where it is and divide by. Is that what I did? I wonder. Hold on. Did I leave the 2? Yeah, I left the 2. And I just divided by y on both sides to start separating my variables. So I would just divide by y on both sides, separate the variables. And plug in, get the c. All right, tell me your answer, and then we'll go over it. Okay, so this is the separation of variables. This is the integral. So I just left the 2. This 2 is this 2, so it's just chilling in front, right? This 2 is a coefficient. This 2, so that inside is 2x plus 1. Now I have to divide by the derivative of the inside, so that's what that's about. Okay, so now I'm going to exponentiate, so it looks like that. Okay, and I plug in, etc., etc. Here's me plugging in. And then I get that, and then when I put this back in, so e to the c is actually e, and then I distribute it through. It's a positive, y is positive, so I don't need the, so there it is, b. Okay, Okay, so when you do a problem like this, you do always want to substitute in to see if it's 0 over 0, because sometimes it'll try to trick you and you just substitute it. You'll try to use some fancy technique, but actually if you just plug in, you get the answer. So you only do, you know, one of my other techniques if you do 0 over 0. Okay, so it is in fact 0 over 0, okay, if you want to convince yourself of that. So how do you do this? I'm going to give you a tip. All right, you want to do L'Hopital's rule. If L'Hopital's doesn't work the first time, if you do L'Hopital's, you still get 0 over 0. You want to do L'Hopital's again. Okay, so go ahead. Alrighty, so you do L'Hopital's. So you take the derivative of the top, put it on top, the derivative of the bottom, put it on the bottom. You sub in, you still get 0 over 0. The top is 0 and the bottom is 4 minus 4, which is 0. So you do L'Hopital's again. So take the derivative of the top, put it on top, take the derivative of the bottom, put it on bottom, so I have times 4 again. And now when I sub in, I in fact get 8 over 16 times 1, which is a half. Yoo-hoo! Okay, for this next one, for number 5, so you kind of want to think, okay, so with x is approaching infinity, or negative infinity, you want to think horizontal asymptotes or end behavior. So you're just kind of thinking, all right, what is going to happen when x is going towards negative infinity? What? This is kind of a Bobo bot in ECC. It's kind of like which thing dominates. Yeah, so try to figure that out. What is going to happen if you plug in a negative huge number for x? So I don't know, try to do like 3 plus 2 to the negative 100 over 4 minus 5 to the negative 100. Like, what would that be approaching? Okay, let's do it. So the answer is 3/4. So 2 to the negative huge number, whether you think negative infinity, negative 100, is really close to 0. Same thing with 5 to the negative infinity, really close to 0. So you get 3/4. Okay, so with horizontal asymptotes and behavior, you can kind of just try plugging in a really huge number, really huge negative number. Okay, let's do number 6 now. Okay, number 6 is the definition of a derivative problem. So I'm gonna let you chew on that and figure out the answer. You take, yeah. All right, let's do it. Here's how I know it's the definition of a derivative problem. If you see h is approaching 0, that's definitely a definition of a derivative problem. There can be another type, but like that always is. So you have to identify, 1, the function. What's the function? Function is ln of x. You can always see the function right there, because this is always f of x plus h minus f of x. So f of x just corresponds to the second thing after the difference. Since it's the definition of a derivative, you want to find the derivative. 1 over x, okay? I actually did it out right here. I don't know why I'm rewriting it. Okay, and then you want to sub in what the x is. There you go. Okay, the next one, a little tip. This is the other definition of a derivative. How do you know this is the definition of a derivative? This should remind you a lot like of slope. y2 minus y1 over x2 minus x1. Slope is derivative. Derivative is slope at a point. So here we go. Let's go. Try to do it. Okay, so my function is ln of x. My function is ln of x, so the derivative is 1 over x. And I plug in the 3, which is 1/3. Okay, so for these problems, a lot of the work is like knowing how to do it, not actually doing it. It's not like taking the derivative itself is hard, you know? Okay. So 8, yeah, we'll call it there, and I'll make another PowerPoint. I'll make another thing for 8 through 11. Okay, bye. See you for part 2. Okay, so this is the final play pause that you have to watch. Woohoo! Yoo-hoo! Like of the year, legit. This is our last new content, like legit. And we're just practicing. So, okay, so this is like when we went over end behavior on the previous one. I think it was number 5. Yeah, I think it was number 5. So write the end behavior. So how you want to think about this, because it's kind of like Bobo bot and ECC, but not quite. So you want to think, if you plug in a huge number, say 100 for x, what would you get? And if you plug in a huge negative number for x, say negative 100, what would you get? All right, let's go over this. So these are the answers. So if you plug in a huge number for this, you would get a very large number on the bottom, right? A very large number. So 3 over a huge number, 3 over a huge number is 0. Alternately, if you plug in a negative number, negative huge number, you would get 3 over e to the negative 100 plus 1, which would be 3 over e to the negative 100. You should make that 0 plus 1, which is 3. If you're just curious, so this has 2 different horizontal asymptotes. It's crazy. This is what it looks like graphically. Yep. Okay, so let's do, so write the horizontal asymptotes. Okay, spoiler alert, it is y equals 0 and y equals 3. Okay, so if those are the 2 end behaviors is synonymous with horizontal asymptotes. Okay, all right, let's do this next one. So do it much in the same fashion. Yep. Okay, so do it much in the same fashion. All right, let's see. If you plug in a huge positive number, so a huge positive number, 3 over e to the infinity minus 1. So this is a huge number. Okay, so I'll get 3 over huge, okay, which is very close to 0. Okay, so that's 0. If I plug in a huge negative number, I get 3 over, so e to the negative infinity slash 100 equals, so this is really, oops, you can't see it. This is really close to 0 minus 1, so this end behavior is negative 3. Okay, so this one has 2 different horizontal asymptotes, 0 and negative 3. Okay, let's do this one, a little review of AROC. So average rate of change, so you're thinking just y2 minus y1 over x2 minus x1. I don't know why I'm telling you this, maybe I should just ask for the answer. Yeah, but so nothing, you just, this is the function, just these are your x values, so figure that out. Okay, this is the work. Fraction work is like fairly tricky, I guess. So this would be 3/6, negative 2/6, multiplied by the reciprocal of the denominator. What's it? Keep, flip, change. I don't know what that is. Okay, there we go. Okay, last problem. So we got average value. Ooh, what's the average value thing? It's 1 over b minus a times the integral from a to b of f of x dx. Let's see. Alrighty, so this is the formula for average value. Every time it says average value or average amount, even if it's a word problem, it says average number of shooting stars. You're thinking that. Okay, so let's do it. So you integrate 1 over x and you get ln. The fourth is from 1 over 6 minus 2. So now you plug in. Okay, and you get that. Okay. I put that in my calculator just like because for the next part. So let's see. So all right, why is this thing? So I sketched 1 over x and I shaded the area from 2 to 6. I don't know. I haven't read this one. Let's call it. The areas should be equal. Okay, great. I'm not going to test you on that. Okay, cool. Thank you very much. This is great. I will see you virtually. Bye.